So this session is going to start chapter 4 of the study guide, but before we get started, there's just a couple of things we swept over quite quickly in the last session, just to complete some of the other things we looked at in the last at the end of chapter 3. If you remember, the last thing we looked at was this date time tester. We looked at all the different methods and classes that you can have in the Java time package, and the main three being, of course, local date, local time, local date time, and then the fact that you can use the now method to create instances of it, or static method. Lots of static of methods where you can pass in all the different bits and pieces to create those objects, and lots of plus and minus methods to actually add things or take things away from dates. And then we introduced periods and durations, where you can model just a part of a time or date in those two objects, and they can be plus or minuses from the relevant types. And then just at the end, we very quickly looked at this date formatter, where you can print your date in a nice way, or a way that conforms to a type that you have to persist, like in a database. We swept over it very quickly, so I just got another example here just to show you. We didn't have this here at the end of last session, so I've added it. And in another class, I've added this constant, this public static final local date, start date of French Revolution. So it models the start date of the French Revolution. We'll come back to this variable here when we talk more about static types, probably in the next session. But for now, it's quite useful to use to finish up our date time tester. So we've created this as a date, 1789 May the 5th. So we're referencing that variable here. First of all, we're going to print it without any formatting, and then we're going to print it using my personal date formatter, which I created here in this pattern here. So if I run that, here is the output of it. You can see the first one, well, it gives you the information you need, but it's not very well formatted. The second one gives a nice format there. So to explore that a bit more, you just need to look at the Java API docs on the web for this class here, and just look at what these patterns are you can create, and they can cover almost any pattern you want. You might want to put it in a specific type that's required when you're persisting to a flat file database, etc. So that's quite a useful thing to be used in everyday business programming. The other thing before we start on chapter 4, I just wanted to revisit, because we did a lot on array lists, and array lists are the only type of collection that is required for us to know on the OCA exam. But another one that I like and is used, is very, very popular, it's just not on the exam, is a map, a hash map in particular. It's very popular use, so I just thought I'd just do a little demo of it here. So if you remember, we had this animal list data manager, which we used about 2 or 3 sessions ago when we were looking at array lists, and we created some new animals, and we created a list here, array list, and we just added those to that list. We added all those animals to the list, and then that list is then passed to whatever client wants those animals, like the zoo in our case. Well, in parallel to that, just a demo, I've also added a map here. Similar syntax, but rather than array list, it's a hash map, and the type is the interface it implements is not a list, it's a map. Again, you can use angle brackets to define the type, and this time we're giving it 2 things in here. One of them is the key, one of them is the value of what you're going to put in that list. So this is probably more flexible. A map is probably more flexible than a list, and easier to use just for convenience, because you've got these keys here. So the same set of animals we've added to our list here, I'm now putting them in the map, and you see the keyword there is put. I'm putting the object against the key. So same set of animals put into our map, and I've just put another method down here, how to get an animal from a map, passing in the string name. You simply have to look in the map and see if it contains the key that you're asking for, and then it will get it. So very similar to list, but it's got this extra thing. The key difference is that this is keyed and this isn't. This is just a straight collection of objects. This is a keyed collection of objects. So not on the exam, but useful to know. So onto the stuff on chapter 4. Well, the good thing about chapter 4 and onwards is a lot of it is revision of what we've already done. So it's revision and then taking it a bit further, applying it a bit more, using best practice standards and that kind of thing. But the first thing that Chapter 4 talks about is the structure of a method, and this is probably 80% revision, because we've been working with methods right from the start. I've got this class called Method Structured Demo, so I'll just plow straight into it. In the Java doc I've put here, I've listed the 8 things you can have in a method. 1 to 8, and they should appear in that order. Well, with one exception which I'll come to later, they should appear in that order. And rather than just reading this list, you can refer to that in your own time. Rather than that reading, that we'll see these in action down below. I mean, even in so we've got 8 things. I mean, we've come across all but one of them just in the main method. We've got our access modifier here. We've got an optional specifier here. We've got a return type, a method name. We've got parentheses, which are vital to any method. You have to have them, even if they can be empty, of course, if you don't pass anything to that method, but you need to have them. Parameters, which have to be in the parentheses if you have them, and comma separated. Then braces to give the, there we go, start and end the method body, and then the method body itself within the braces. So all of those are demonstrated just in the main method, which we're familiar with. The other one is that you can throw an exception. That's the other thing that can come in here. We'll add that later on. So just a little general look at those different components of a method. Access modifier, well, we do a lot about access modifiers later in this chapter. Public we're familiar with. We can also have private like that, or protected, or we don't have to have one at all, a word at all, but that still has an access modifier. It's default. We don't use the default word because that's used elsewhere in Java. It's used, for example, in a case statement. But if you don't have any word for an access modifier, you have the default access modifier. What they actually mean will be explained when we come to access modifiers later in the chapter. But just to note, to run a main method, it has to be public in there. Even though all these others actually compile, if we then try to run that, if we try to run our method data structure like that, it will tell us that we don't have a public main method. There it is. We don't have a public main method. So it compiles okay, but you can't use that class to start a Java thread. It has to be public. Now it would run just fine. So it's going to print hello and welcome to method structure demo. So that's access modifiers. As we've said, so this shows quite a lot of the components. This is about as minimal as you can get for a method, but it still shows 5 of them, believe it or not, even though it doesn't look like it. It has got an access modifier. It's default, even though you can't see it. As we said before, if you don't write public, protected, or private, it's default by default. The return type is there, void. And you must have a return type even if you don't actually return anything. If you don't return anything, it's simply void, and we're used to that here. Because here, for example, we're just printing something out. We're not returning anything to you, so the return type is void. The name is there, the parentheses are there, although there's no parameters in them, and there's the method body. And even though there's no actual code in that method body, we've got the parentheses, we've got the brackets, so that makes it a valid method. Another thing to point out is that the order is important. So that doesn't work because we've got the return type before the access modifier. The order is important, but generally speaking, all 8 of these have to be in the order listed here, but there is an exception to that. These 2 can kind of be mixed. I'll demonstrate it in a minute. The access modifier and the optional specifiers, they can kind of be in any order or mixed together. The way to think, it's confusing, but the way to think of it is that those 2 together can be considered as modifiers together. We'll look at that in a minute. I've got an example that shows that in a minute, what they are. And just to confirm, if we actually try to use the default keyword as a modifier, it doesn't work. If you want something to be default, you simply have to not have the access modifier at all. There's another very minimal one like that. So return types, as we said, if we are going to return something, so our return type is not void, we have to actually return something. So here we are returning 5. If I took that away, it no longer compiles. You see there's a red squiggle there. So if you declare you're going to return something, you have to return it, and it's no good just doing that either, because you have to actually return something. In the case of a void method, you don't need to have a return statement, but what you can do if you want to, even in the main method, you can simply do the word return, which tells you you're returning control of the thread to whoever called you. You don't have to do that because it happens automatically, but if you want to, you can put it there. But if you try to return actually something in there, like that, it fails because this doesn't match that. So that's about return types. And this also talks about the optional specifiers. So optional specifiers are the second thing in the list. We just dealt with return type, the third thing in the list, a bit out of order here. So what they do is we only need to know 3 for the OCA exam. It's static, final, and abstract. And some of these work you can use. So here we have 2 of them. Abstract doesn't work with these 2, but these 2, they work either on their own, like that, or together. You can have one together, but neither of them work with abstract. And also you can't have abstract here, because to have an abstract method, it has to be in an abstract class. That comes in chapter 5. So what we've done, just to show that, I've actually created a in this package here an abstract animal. So this is actually an abstract class, and here this is allowed. This is allowed here, but it's not allowed in a normal non-abstract class. So just go back to that again. There it is. So I'll return it to what it was before. So as I said, these are optional modifiers. So static, as we've already dealt with, that means that this method is something that is owned by the class. It's not owned by any instance of the class. Final means that no one can override that. No one can create a subclass and then override this method. We're saying here that this is the definitive declaration of this class, and no one's going to change it. And if you think of it, was appropriate here. This method is called give me 5. It simply does return 5. So it makes sense for it to be static. It makes sense for it to be owned by a class because it doesn't depend on any state from any other objects. It doesn't need you to, for example, to log in and give your name or anything like that, which would depend on object instances. It just throws you a 5. So in the same way as those date methods, like local date, local time, they could create an instance of date just with their now method or their old methods, because to create a date or time, you don't need to have any state from any other objects. You don't need to know someone's name or bank account number or anything like that. You just need to grab a timestamp and throw it back. It's the same here. Static methods are very good when you don't need state, and they save memory as well, because you only need to have the one method per class as opposed to per instance. It also makes sense to make it final, because we're saying give me 5 here. Well, we're never going to want to override that to return 6. It's always going to want to return 5, so let's make it final here. Makes sense to make it final. In the same way that something like the string class, for example, is final, the entire class is final because the developers decided that that's it. That's the definitive declaration of this class. We don't want anyone else messing with it. So it's marked final. Same here. What we can do, just to show, this is going back to sort of chapter 2 stuff really, but just to show, if we comment out that and return 5L, which is a long, that fails compilation, because this, we're returning a long and we're saying that this needs an int. So you can't stuff a long into an int, it's too big. You can do this to make it compile, and then once you've done that, the int is still compatible because you can stuff an int into a long, so that's compatible, but it has to be the right way round. So there's a lot of examples in the book about return statements, return statements here, and this is about as complex one as you can get. So if you understand this one, you can pretty much understand them all really. So and there's quite a few examples in this class, by the way, where I've kind of commented stuff out and I've asked the question, does this compile? So if you want to work these out for yourself, you can always pause the video at that point, try to work them out. There's several examples of that. But if we uncomment this one, what we're saying is we're saying that this returns a string. This returns a string. It's got default access. It returns a string, and we're passing in an int here. So we're saying if that int equals 4, you return I walked 4 miles today. So on the face of it, it looks like it's doing what it should do. You're saying that you've got a string, and you're saying here that you're returning a string, because obviously if you didn't have that, it wouldn't compile at all, because you need to return something. But actually it still isn't compiling here. It's saying missing return statement. So why is that? Well, that's because what we pass in might not be 4, and therefore flow would return to here, like that. And so here we'd have to say I didn't walk 4 miles today. And now it compiles. And also it shows you something here as well. We did if statements in chapter 3. If you don't, we used to have if else's, but if you think about it, you don't need the else here, because if this is 4, you're going to get a return there. It's going to return control out of this method immediately. So it will only get to this point if that was false. So you could wrap this up in an else, but actually you can just do it without the else, because if it even gets there, you know that wasn't true. So just to repeat what we were saying before, you can't have abstract and final together, or in that matter, abstract and static. We'll come to that when we deal later on with static variables and methods. But the reason you can't have final and abstract together is that they're the opposite of each other, really, because final means that you can't extend this method and override it later on in a subclass, whereas abstract, it means you have to. It's the opposite. You have to extend and override it in a subclass, as we'll see when we do when we do overriding and abstract classes. So those two optional modifiers are not valid together. But as we saw before, final and static are. So we only need to know final, static, and abstract, and we need to know that abstract doesn't work with the other two, but the other two work fine together. So that's those two. So here's another list based on what we've just discussed about to try to see which of these will compile. So I'll uncomment each one in turn, and if you want to pause and just try and work it out yourself, you can do. So that compiles fine. It's got all the components it needs. That does. That does. That does. I won't explain why they do, because we covered it earlier on. Those two don't, and that one does. So the reason that these two don't, of course, is that modifier there, that's not a valid word. The modifier has to be, an actual modifier, final, static, or abstract, or whatever. It can't be the word modifier. And this one, it has the return type before the modifier there. They have to be in the right order, except for the special case which I mentioned, that the access modifiers can be before or after the optional modifiers. Or here, this is an extreme example, they're actually kind of matched. So that's an optional, that's an access modifier, and that's another optional. So you could put those in any order. And by the way, it's far better practice to have the access modifier first. You could have them like that, or you could have it that both of these are before this one, like that. But by far the best one is to have them like that. That's the best practice. We usually have the access modifier first. So I'll just comment back the ones that didn't compile so we can carry on with the demo. So name is the next one, and method names, again, this is revision, because very early on we talked about identifiers and what are valid characters in identifiers. I've copied that class here. We did this in, I think, chapter 1, and we said that identifiers, so this is for variable names, but now we're doing it for method names, and it's just the same rules. They must start with either a letter, dollar, or underscore, or pound, but that's not on the exam. And other special characters don't work. You can't have a number at the beginning of it. So none of these compile. This is with variable names here. So none of those compile. And exactly the same rules apply for method names, and the same conventions as well. Like ideally, we would have camel case like that, and no special characters really. We try to avoid them if possible. But here we have so up to this point was what we did in an earlier chapter, but here this is the added bit for chapter 4. So again, we tried to see which ones of these will not compile based on what's allowed in the method name. So I'll go through each one in turn again. That one's fine. That one isn't. That one isn't. That one. So 4 of them aren't, and 2 of them are okay. So that's fine. We've got a numeric type there, but it's not the first character, so that's okay. The second one is the character, so that's no good there. This time again, well, it's not. It's for a different reason, really. This is because the return type is before the method name. So that's for another reason. This one's okay, even though it's not good to have a capital letter to start your method name, or underscore or dollar, they are allowed. So even though it's not best practice, they are allowed. This one doesn't even have a method name at all, so that's certainly not allowed. You have to have a method name. And this one contains illegal characters. So what I'll do, I'll just comment again the ones that didn't compile. And that covers method names, exactly the same conventions that we use for identifiers when we talked about variable names. So that's this one. So the next thing is the parameters list. So we say, as I said, we have to have parentheses. We absolutely have to have them, even if we don't have parameters, as we don't in any of these examples. But if you have parameters, they have to be inside those parentheses, and they have to be comma separated if you've got more than one. So again, we've got a list here. Let's see which one of these compile and which don't. So I'll just... Okay, so this is fine. This is a bit like these examples. It has the parentheses, nothing in it, and a minimal method body. This one doesn't have parentheses at all, so that definitely doesn't work. This one's fine. It has parentheses and a single variable. This bottom one is fine. It has parentheses and 2 variables, parameters, separated by a comma. And the problem with this one is it has 2 parameters, but they're separated by a semicolon, which isn't allowed. So that's why that doesn't work. So just comment those out again. So the only thing we haven't covered with method signatures is the final thing, is the ability to throw an exception, which is the first time we've seen this really on this course. So this method here demonstrates all 1 to 8 of the things listed at the top, all the method elements you can get. The final one that being throw an exception. So what does that actually mean? Well, what that means is that this method contains some lines of code that could throw an exception if things aren't right. So for example, what we've got here, we've got some standard code here to read and print the lines out from a file on the file system. So as you can imagine, if that file doesn't actually exist, that you're telling it exists, it can throw an exception. You can say, oh, hang on a minute, I can't find this file not found exception. So if we're using code that might do that, we either have to deal with that possibility right here, handle it right here, or just throw it, which is kind of like deferring the responsibility to the client. And that's the easiest thing to do. To demonstrate that, if we get rid of this and just have the standard brace like that, now it's not compiling. It's saying, hang on a minute, this could throw a file not found exception, and this could throw an IO exception, input output exception. What are you going to do about it? So we say, well, do you know what? I'm not going to handle it here. I'm just going to throw it so that whoever calls me can deal with it. We deal with exception handling in chapter 6. So that is exception declaration in a method, and it's interesting to know as well, because you quite often get questioned on what's allowed in a main method. You can quite happily put it in a main method too, like that. Throws exception. So that still works and it still runs as a main method. If I run that again now, that's fine. You can have that, it still runs as long as it's public, static main void, and with the string args array parameter, that works. So what I'm going to do now, I'm going to call that file below. I'm going to call it, the file I just went through below earlier on, I'm going to call it and I'm going to say to it, print this file, which I know does exist on my file system. So it'll print that. And it's read the contents of that file, which is that. If I now comment that out and read one that I know doesn't exist, so that doesn't exist on my file system, and run that, we have a file not found exception. It tells us that it was originally thrown from here, this here, when the file reader tried to find a file. Then it got passed to here, where it was thrown and handled by the JVM, because it can't go any further than the main method. So if you throw it from there, it'll simply get handled in the JVM like that. So that's the final part. That is the exception, throws exception section of a method signature. And just in passing, I noticed another thing just to demonstrate about method bodies here. We've got some method body examples here. Of these three examples, just that one doesn't compile, because you do need to have that to make it a method, even if there's nothing in it. And lots of the examples, even though it looks strange, because of course in real life you would always want to have code in these methods, but it's quite okay to just declare them like that, so they haven't got a return type. So that covers the structure of methods in the first part of Chapter 4. And the next subject on Chapter 4 is varargs, or variable args. And if you remember, we did say that, so I've got a testing class here, and these first couple of methods here are not the main method. I'll come back to them in a minute. But we did say that actually it's quite okay to have your main method signature to look like that rather than that. And that works fine. That will run, because string ... this ... that indicates a variable arguments. That means that you know you're going to get strings, but you don't know how many you're going to get. So very similar to array, but a bit more flexible. I'll change it back to that in our main method, because we're more used to it. And then just go back to these two methods above. Now there's some commented sections which I'll come to in a minute, but if you just see what's uncommented for now, both these methods, these are pretty much identical. This one takes a string array, and this one takes some string varargs. So this is going to be, we're going to pass in strings, but you don't know how many. It could be 0, 1, 2, 3, 4, etc. This takes in an actual array of strings, and all they're both going to do is print the contents of those things you pass to them here and there. So from the main method, we can just print them, print array and print varargs, and we're actually passing an array into both. Now that immediately might look strange, because this one, print array, does indeed take an array, but print varargs doesn't take an array, it takes varargs. So that's the first thing to learn about varargs. They're flexible. You can either pass in strings directly, or you can actually pass an array. So these two methods can kind of be treated the same regarding sending an array in. So if I just run the varargs demo there, we should get both of those running fine. Yeah, so it's printed both lists out twice for the two methods there. You can't declare a varargs actually as a variable type in your code. So you can't do that, for example. You can't say, oh, here's a varargs, I'm going to call it Nick, Andy, Adam. It doesn't work like that. The whole point of varargs is they're designed to work inside methods as a convenience to you. After all, it can be a bit of a overhead to actually create an array like this and put things into it. You often have to think of sizing and that kind of thing. Whereas this varargs allows you to just throw strings in as they are, which is shown here. So if we but you can't have them as a variable type. The variable type string args, variable varargs doesn't exist, so that doesn't work. But to demonstrate how they do work, so this print varargs method again here, we already tried it. We already printed it with an array in it, and that worked fine. It got all the array elements out and printed them. You can just call it like that with nothing in it, so that'll obviously just print nothing. Just run that to show you. We'll just repeat this again, hopefully, with an extra blank line there. You can pass in arrays like this, which is the same. That's the same as what we've already done, really. So we've got Nick here. So just do the next two the same, just to show that you can call it with. So this is printing it either with nothing or with array arguments. But here's where it really comes into its own, because the whole reason for using them originally is that you don't want to use an array. So you can print them like this. Just pass the strings in directly. Just pass the strings in directly like that, and that works just fine. It's all the same stuff. Much more convenient than doing that, and you don't have to think about sizing or declaring an array or anything. You just pass your strings in directly. Now if we go back to our print array method again, we can call the print array method exactly as we did here for print varargs by passing an array in. So that works fine. That works absolutely fine. But this shows the flexibility of varargs, because what we can't do, we can't pass in varargs to a method that's expecting an array. So print array expects an array like that. So you can't just pass varargs to it. But the print varargs, that expects varargs. So you can either send just a list of strings, you can send an array. It's flexible. You can send either an array or just strings comma separated like that. So that's where varargs are very, very handy for us. And here's another example here. So we've got this method walk, and we're going to call that with various different times. And what it's going to do, it's going to take in two parameters. One is the start, and one, even though it's not used, it's just to show that you can combine varargs with standard variables as well. And it's going to print what the length is in each case. So if you look at those examples, the length there is going to be 0 because the first one is the start and the second one is the varargs, but there's nothing there, so it's going to print 0. That's going to print 1 because there's one thing you're passing in there. That's going to print 2 because there's two things you're passing in. And that's going to print 2 because there's two things you're passing in, but in an array. That shows that flexibility again. So if I run that there, we're expecting a 0, 1, 2, 2. And there it is. So that worked absolutely fine. And there's example here, you can actually pass null in there as well. Even though it's confusing, it effectively has the same effect of this first one, but it's a null pointer exception in there for doing that. And that's because the method itself tries to read the length of what you're passing it, but you're passing null in there. So you're trying to achieve the same as this here, but the fact that you pass something in there, even though it's null, it tries to do something with it. Tries to call length on a null object, but that doesn't work. So it fails compilation there. And the vital thing to remember about varargs is that if you do define a method that takes varargs, there can only be one of them in a method signature. So you can't have two, like that example here. And they can only be the last thing. So you can have other variables in there. So these examples have other variables, but they can't be. They can only be the last thing in a list of variables. That's just for ambiguity really. Like say for example you had 3 string arguments and then a vararg of strings. So you know you were having 3 standard strings and then as many strings as you want to. So it's important that that comes last, because if it didn't come last, it could be ambiguous. The compiler might not know where your varargs stop and then your next variables start. So just have a look at some of these. Again, they're commented, but I'll uncomment them. We can see why. This first one is fine. It takes a vararg of ints, so that's absolutely fine. This one is fine. Second one, it's kind of like this one here we just did a demo on. It takes an int argument, then it takes a vararg of ints. So this is where you see this rule. This one is attempting to do the reverse of that. Walk 3 is attempting to do the reverse of walk 2. If you're going to have another variable as well as your varargs, that has to come before it for it to work. So let's just get rid of that and put it there. That now works. I mean, it's exactly the same as the previous one. So I'll undo it just for the demo purposes. Exactly the same here, but here you have 2 varargs. So you definitely can't have that. Say you pass 12 arguments into that method. How would you know where the first one started and the second one started? The first one stopped and the second one started. Again here, you're trying to do it the wrong way around. You've got a vararg of nums, of ints, and then a string. If you wanted that, you'd have to have the string first. Golden rule, you can only have one of them per method, and they have to be the last thing in the method signature. So I'll just comment out the ones that didn't compile. The only other thing to mention now concerning varargs is how you access the elements in a vararg. And it's exactly the same. So I'll go back to these 2 methods again up here. I've got this is my print array method, and we're used to doing this. We're used to referencing it by square brackets and then the index to it there. It's exactly the same in varargs. Varargs are referenced as though they were an array like that, so square brackets and a 0 in it there. So that's pretty much everything we need to know on varargs, the second thing to deal with in Chapter 4.